Great seeing you, Nick. Thanks so much for joining us.
Really happy to be here to show you the product of the collaboration that we've been working on and try and articulate in a vision demo how we see the airline industry transitioning and how we see digital capabilities enabling Rolls-Royce services in the future.
Fantastic.
We've been providing using and providing data and analytical services as part of our engine services for a couple of decades now, and this is such an exciting time to embrace the big data technologies, using your platform, using machine learning, and using our own engineering models and engineering know-how, as well as the operational know-how of our customers to provide a better service to the aviation industry. So the demonstration we're building is a representation of how we see the industry collaborating in the future. There are many parties all trying to deliver better service to the airline industry and to us as passengers. No one party can do that. We believe collaboration is the right model, and I'd like to show you how we're planning to enable that. So putting everything together in one place for an airline operator is quite novel. There are many, many different systems drowning in lots and lots of data. So the industry does not have a shortage of data. The industry has a shortage of insight and a shortage of intelligence. That's not because our customers aren't intelligent and Rolls-Royce isn't intelligent and Boeing isn't intelligent and so on. It's a lack of consistent information in the same place being managed, processed, analysed and visualised in the same manner. It's really important for us as a company to share information with our customers. And our model of collaboration with customers enables us to build their operational insight and knowledge into our solutions. What we're going to talk through here is an example of how this broader collaboration comes together. I'm just going to tell you a story of the day in the life of an airline and how a particular problem with a Rolls-Royce engine can manifest itself and what, through digital technologies, we're going to do better in the future to drive better business performance. Our overall goal and our customers' goal is to understand where their airplanes are, how they're operating, are they serviceable and are they healthy. To have a vision of the global operation of this particular airline is quite powerful in its own right. To understand how the business is operating and to understand how efficient that operation is key to our customers, as you can imagine. On the surface of an airline, to us as passengers, punctual, safe performance, on-time performance is all that counts. So to be able to monitor your on-time performance, the utilisation of your assets, your engines and your airplanes is critical. To us, though, in the provision of better services, it's what happens behind the scenes that really counts. It's the amount of stress that goes in to meeting the customer intent, to meeting the mission. Generally in airlines, there's an awful lot of activity to get the airplane away on time. And we're measuring that through analytics and better sharing of data. The goal of the airline is on-time performance. Critical, they keep that at the top. That's the number one competitive differentiation. Anything we can do to prevent surprises and be proactive is critical to our customer. In this example, we're talking through a vision of a particular aircraft. This is an Airbus A350 aircraft with our Trent XWB engine. On one of these aircraft in particular, the only one that the airline really should be bothered with analysing and investigating today, we have a suspect fuel pump problem. So this is analytically driven. This isn't being driven by the life of that particular component. Every machine and every component is unique. It's like a human being. We tend to treat these things as the same. So we give them the same life. We manage them in the same way. So an awful lot of components are thrown away with remaining useful life on them. The goal in these types of systems and in the future of our business model is to really apply prognostics, to really use prognostics and analytics to determine when biologically something is going wrong with a component, to act upon it before it manifests itself as a delay or cancellation. So we can see in this screen one red issue, and we can see here one red aircraft. So let me just take you through what that means. So on the day of flying in the airline's operations centre, using these technologies, we can now focus in on the one aircraft that they ought to be paying attention to. So the one asset they've got that may be in difficulty or may have to have some maintenance intervention. We can see that that aircraft is in Frankfurt. We can see that through this alert watch here, which is a aggregation of all sorts of different engine, airplane systems that comes up to a view of those systems that may need intervention, we can see still that in our early watch list, the fuel pump may be a bad actor. So if I drill down one more time into that screen, we're now seeing our A350 aircraft in a lot more detail. We're now seeing the planned route for this aircraft. So this aircraft is in Frankfurt. It's going to be flying to Seattle in about 3 hours, 45 minutes time. So we know the window of opportunity here. We've got all of the operational and maintenance information we need in one place. We know how this aircraft has been flown. We know whether it's operating efficiently. And we know that the remaining useful life of the engines installed in this airplane is normal. We also know that the airline is doing a good job of managing its fuel. So millions and millions of tons of fuel per annum can be saved through better management of fuel in the aviation industry. So working with analytics and pilots and others in our customer base, we're able to manage the levels of fuel that are being flown. So we really now want to take a look at this particular propulsion system issue and delve down into a little bit more detail. So now we're starting to see the digital detail of our Trent XWB engine. So the engine here is exploded, so you can see the inner core of the engine. And we're starting to look at parameters now which are more pertinent to the engine itself. Where the engine is fitted, its current level of performance. So is it operating normally? Is there any need to intervene? On the surface of things, there isn't. And frankly, this engine and airplane will carry on operating successfully and happily for another several flights. What we're doing here is being proactive, and we're pulling forward potential issues. We can see here that the engine was washed recently, but the fuel performance is starting to deteriorate. So again, in our machine learning and modeling capabilities, we're able to predict what the normalized fuel burn for this engine is. Using analytics, we're able to predict a point when it's economically viable for our customers to wash our engines to get their fuel and performance back up again. So again, a novel use of analytics that helps add value to our customers. We can see here, though, that our fuel pump is potentially the bad actor of all the green systems and all the green indications here. We'd like to go and take a closer look. We're now in the engineering world of our customer's organization and in the engineering world of Rolls-Royce. So we've driven right down through the system to the point where we're looking for verification and validation through analytics that this is a bad actor, that this fuel pump may need to be changed. This is what we believe our customers are looking for in terms of trusted solutions to analytics and trusted output. So in this arrangement, you can see here, there are a number of standard measures that we would use in our engines to monitor the health and integrity of them. So you can see here a fuel pump speed chart. Its speed increases, it decreases. It's depending on how much fuel it's pumping into the engine. You'd expect that. But there's some fluctuations here which may be abnormal. You can see here that the amount of power, the amount of electrical power that's being pumped into that pump may be exceeding expectations. So maybe there's a bearing that's starting to wear or there's some mechanical issue in that pump. So while it's healthy from a life point of view, it may not be healthy from a mechanical point of view. Everything is different. Everything needs to be managed and monitored in its own way. So now we start to get into additional levels of prognostic capability where the real intelligence in the analytics are starting to come together. We can start to see that the derived pressure readings in the pump are varying beyond normal expectation. We can start to see that the amount of fuel that the pump's actually producing, given its power and given its speed, isn't where we expect it to be. But we still need more. So we're using Cortana and other modeling and machine learning capabilities to understand what normality is for the components in our engine. How should it be operating? Let's take away what's normal, let's look at the rest. And in these types of models of normality, we're able to magnify what might be going wrong within the residual data. So really intelligent application of machine learning capabilities. And we're able to do that as a function of the collaboration with you. We're able to determine from this that this pump is subject to a potential problem. We're able to determine that the aircraft is sat in Frankfurt with 3 hours, 45 minutes on the clock until it takes off to Seattle. Through this and the linkage to CRM and other capabilities, we're able to determine that we have the people and the time in Frankfurt to intervene and make this maintenance correction on the airplane. Again, our goal as Rolls-Royce is to keep our customers flying and available 100% of the time. So it's prudent for us to recommend that action to intervene. In requesting that maintenance, it's obviously in a regulated, safety-critical environment important that we record what's happened. So here is an example in terms of the fuel, in terms of this particular fuel pump, of where this component sits on the average life for such a component. So we're saying it's actually still healthy from a life point of view. We're saying the aircraft and the engine can operate quite safely and quite satisfactorily to the next maintenance window. But if that aircraft becomes stuck or delayed at an away from base location where this activity couldn't be carried out, or this boils up into a more serious problem for the airline, we think it would be prudent to intervene now, be very, very proactive, and have this maintenance done. So the linkage of the physical in the engine, the digital in terms of the processing of data and the visualization of data, now moves into the confirmation that we want actionable insight and we want people to go and intervene and do this work. In our system now, we're talking to the maintenance planning systems, the ERP systems. We've already confirmed that we've got the people. We've already confirmed we've got the parts. We now need to dispatch the crew, record the work, which is where we now link into the CRM capability. So the vision for Rolls-Royce is to seamlessly link our in-service customer digital capabilities through our physical services into CRM to make this action real, to make it actionable and recordable as far as our customers are concerned. So here is a list in the CRM tool of all the activities that need to be carried out and all the maintenance events that need to be carried out. There are several windows for that particular information that you'll recognize in your tool here, and we'd like to go away and ensure that that work can be done. So now we're into the scheduling tool to actually look if we've got the opportunity to schedule that window. We know we had 3 hours 45. We know the work's going to take about 2 hours. It's a matter now of scheduling that work to be done. So let's drop it into a window for the right maintenance engineer to be able to do that work.
This is using all the new field service capabilities and the latest dynamic CRM. It's awesome.
Bringing this together from an end-to-end point of view, scheduling that work, having it done, keeping the engine flying, keeping the customer happy. That's our vision of digitally enabled total care.
That's awesome. Thank you so much, Nick. I mean, this is someone who flies a lot and appreciates when his flight connection doesn't get interrupted. This is fantastic as an end user, and I think it's just an amazing example of the type of digital transformation and digital strategy that you guys are driving, which, to your point, connects IoT, data analytics, and field service all in one. Really impressive stuff.
Pleasure.